What's happening in year 10? Today's lesson is on something called Frustums. It's clip 578 on Hegarty Maths. And your questions basically in this exercise fall into two categories, ones that look like this and ones that look like this. So questions 1 to 4 are the same as that one, 5 to 10 are the same as this one. Right, now frustum is a type of shape that you haven't seen before. Effectively what it is it is a cone or a pyramid with the top chopped off. So if you imagine like an Aztec pyramid, you know, they have the altars on the top, like an Aztec pyramid would have like a little square on the top, and then it would sort of come down like that. That's a frustum, okay? That has had the top of this pyramid like that taken off it. Now the ones that we're looking at today are cones with the top chopped off. So they basically look like that, okay? So what we need to do is figure out the volume of one of these things. Very, very easy. Basically what we do is you imagine this as one big cone, figure out the volume of the big cone, and then subtract the volume of the cone that has been taken off the top. Okay, so there's a few steps to this. You're going to be using the formula that we used in the previous lesson, which was volume equals 1/3 times pi r squared h. And what you're going to do is you're going to do that for the little cone that's gone. You're going to do that for the full cone, and then you're going to take them away, and that gives you what's left down there. Okay, so the way we're going to do this is we're going to split it up. We're going to do the big cone there, we're going to do the little cone here, and then what that'll give us our answer. So the big cone has a radius of 10 and a height of 18. Okay, so the volume for the big cone for this one will be 1/3 times pi times 10 squared times 18. And we're going to put that all into our calculator. 1/3 times pi times 10 squared times 18. And that gives me 600 pi. Now, one little thing with this is because it's saying there to give it to one decimal place, the best way to do this is to keep these answers. That's not going to be my final answer. The best way to do this is to keep it at 600 pi, get this one in terms of pi as well, and then when we subtract it at the end, we can then look at rounding it. Okay, so our big cone, which is that one that has a height of 18 and a radius at the bottom of 10, has a volume of 600 pi. The little cone is this one up here. Now that one has a radius of 5 and a height of 9. So let's do exactly the same thing for that. 1/3 times pi times 5 squared times 9. And again, put that into your calculator. So 1/3 times pi times 5 squared times 9. That gives me 75 pi. Okay, so the volume of the frustum equals 600 pi, which is the big one. Take away 75 pi, which is the little one. And what we can do is just plug that into our calculator. 600 pi minus 75 pi. That gives me 525 pi. You figure that out without using a calculator. But then because it wants it to one decimal place, press the SD button. So that's 1649.3. Centimeters, yeah, centimeters cubed. Okay. What you could do here, by the way, if you wanted to, is put all of that in as one big sum. So you could do this thing, put that into your calculator, then put a takeaway, then put that into your calculator, and it will get you straight to that answer there. Okay. When you're doing this, you do not need to write out big, little, volume, all that kind of stuff. I'm doing that to show you exactly what it is that we're doing and why. Okay. So that is for questions 1 to 4. So if you wanted to pause this now and go and do those and then come back, we'll have a look at 5 to 10 in a second, or if you just want to carry on watching, that's fine. Right, the second type of question then looks like this. Now, if you just have a little look, obviously they look very, very similar because you are figuring out the volume of a frustum, but can you spot what the difference is here? What has changed in terms of how they are giving you the question? One thing is they're asking for the answer to 3 significant figures at the end, so we can deal with that later on. Okay, we're going to do the same process. We're going to do the big cone, take away the little cone, and then figure out the volume of our frustum. The difference this time is that they haven't given you the height of the big cone. They've given you the height of the actual frustum itself. They've given you the height of the little cone. So all we need to do is spot, and it's dead easy to do this, what the height of the big cone is. Well, if that height's 9 and that height's 18, then the big height must be 9 add 18, which is 27 meters. Okay, well, that's the only difference there. So the big cone will be 1/3 times pi times 12 squared times 27. The little cone will be 1/3 times pi times 4 squared times 9. And then once we've got that, we do exactly the same thing. Okay? 1/3 times pi times 12 squared times 27. So this one gives us 1296 pi. 1/3 times pi times 4 squared times 9. This one gives me 48 pi. Then I'm going to take them away. So that gives me 1248 pi. So when I get that on my calculator, it wants it in 3 significant figures this time, which means that we want it to stop. Effectively, we want only 3 digits in this thing that aren't 0. So we want 392. So it means to round it to that column. That's in the tens. It's got a 0 next to it. So my answer there is just 3,912 meters cubed. Okay. So for the first 4, you're given the height of the big one. So you do that one for the big one, that one for the little one. On the next few, you just have to kind of figure out which ones, what the height of each cone is, basically. Okay. So on this one, you were given the height of the frustum, given the height of the big piece that's missing, which means the entire height of the big cone would have been 27 there. Okay. So as always, any issues, let me know. Good luck.